Given f of x equals x squared minus 1, evaluate the following, starting with f of 3. Well, as I get familiar with this notation, that is f of x, I recognize that the x part of this is that part that's inside the parentheses on f of x. So when I come down here to f of 3, 3 is the part inside the parentheses. That must be my x idea that I want to plug in. So if this is my x idea, I come back up to this function and how it's defined. I look for the x's. F of x equals x squared minus 1. Wherever I see an x, I replace it with my x value down here. So I replace this x up here with a 3, and apparently square it, then subtract 1. I do some highly advanced mathematics. 3 squared 9, subtract 1, get 8. So given that f of x equals x squared minus 1, f of 3 would equal 8. Got my answer. What that means as I compare back to the function actually gives me a point now that's on that function. When x is 3, f of x is 8, so f of x, y, interchangeable ideas, the ordered pair 3, 8 would be a point on that function. That's what that means. Little extra tidbit for you there. So if we are asked to find f of 0, inside the parentheses here, that 0 represents my x idea. Go back to the function as it's defined, replace any x's that you see with 0. So you've got 0 squared minus 1. Do your mathy stuff. 0 squared, 0 minus 1, negative 1. F of 0 equals negative 1. Gets slightly more interesting down here when you got negative values involved, because negative values sometimes cause some sign issues, so be careful on how you're substituting. But if we go back up to the function as it's defined, we recognize that f of x equals x squared minus 1, and the x here is being squared. Well, if I'm squaring the x idea, I should always get something positive back. That means as I plug in and show the substitution here, those parentheses take on a little more meaning. Right? Negative 2 squared like that, minus 1. Negative 2 squared would be positive 4 minus 1. F of negative 2 equals 3. Right, so same rules as before, different function. Whatever we see inside the parentheses here, after our g notation on this one, that represents the x value. That's the value that we want to take. We want to plug in over here for any x's that we see. So in this first one, g of 4. I'm taking 4. I'm plugging in for x. In my defined function, g of x equals square root of 5 minus x. So this is going to equal the square root of 5 minus, would be a little over the top here, use parentheses 4. Parentheses really aren't required because it's just the square root of 1, right? And the square root of 1 is 1, so g of 4 equals 1. All right, same idea, g of 3. I want to replace my x in the function that's defined here as g with 3. So I take 3, I plug in. I've got the square root of 5 minus. Once again, if I'm over the top here, as I substitute, I'm using the parentheses, replacing that x with a 3. If that is just 5 minus 3, which is 2, square root of 2 is what I have. As far as I'm concerned, I like exact answers. So we know that's an irrational value. We know if we took the square root, we get this non-repeating decimal, so let's just leave it as the square root of 2. Acceptable answer. So what about g of negative 2? The game remains the same. You're taking negative 2. You're replacing the x back up here with that negative 2. You've got the square root of 5 minus, if I use the parentheses, negative 2 like so. Parentheses slightly more significant this time because it's negative. We can see that the double negatives create the positive. You got 5 plus 2, you get the square root of 7. And I'll leave it as square root of 7 for the same reason I left it as the square root of 2 in the previous one. Now you're feeling pretty confident. You're feeling pretty good about yourself. Try number 7 there. Go ahead, try it. See what you get. Got the square root of 5 minus 7. Oopsie, that doesn't work so well, does it? Square root of negative 2. I can't take the square root of negative, can I? So, on that, right? G of 7 doesn't work. So G of 7 does not exist. No solution. All right, so composition of functions. We're given f of x, given g of x. Let's find f of g of 3. That's how we'd say this. Now to find f of g of 3, I'm going to actually rewrite this so that it's in this other composition form. I like to write it where it's f of g of 3. Because what that allows me to do, it allows me to kind of work from the inside out, a little more consistent with my order of operations and what I'm used to there. Start with the number. I'm taking this 3, which follows g here, meaning I'm supposed to take 3 and plug into the g function as it's defined. So g function up here as it's defined, g of x equals x squared. So this 3 replaces the x in that function, meaning I haven't done anything with f yet, but I'm going to take the 3, replace the x up here, right? That's being squared. And put that in the place of g of 3, because I know that's what g of 3 equals. Now, of course, that's 9. So what am I trying to find now? I'm trying to find f of 9. So, for your function defined as f, this guy over here, wherever you see an x, I see one right there, I'm going to replace that x with this value of 9. If I do that, I've got 2 times 9 plus 1. This means that f of g of 3 is 18 plus 1, also known as 19. Okay? All right, so same 2 functions. We're going to find g of f of 2. Just like I did on the last one, I'm going to start by rewriting this where it's g of f of 2. Start from the inside, work my way out. So start with this 2. I'm going to take this 2. With the f in front of it, it's telling me plug into that function f for any x's that I see. So here's my function f. For any x's that I see, I'm replacing those x's with 2. So this will equal g of, replacing the inside with what f of 2 is. It's going to be 2 times 2 plus 1. Of course, that's going to be 5. So you got g of 5. Now we've got g of 5. We go to the function g as it's defined. It's defined as x squared. Any x's we see in that function as it's defined, we replace those x's with 5. So I see 1x being squared. I take 5, square that. G of f of 2 is going to equal 25.